And now that I'm getting off my high horse,
here we go.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 136. Today we're talking about smacking asteroids, decoding Voyager, milling cheap, and PS5 triggered. Elliot, it's time for Remoticon.
Woohoo! I mean, kind of woohoo. I so wanted to do actual SuperCon this year, but we all know the situation does not allow it.
Oh, I totally wanted to do it. And, you know, the thing that we were looking at was doing like a smaller in-person thing, potentially at the Supply Frame headquarters. And we can't do that, but we can have an awesome time in November at the Hackaday Remoticon, our second remote virtual conference, but we're changing it up. So like last year, Elliot, we had workshops.
Right?
This year, we're doing talks. So it will be different, and I can't tell you the details. Well, I can tell Elliot the details. You already know, but we have.
You can't tell me the details?
We have some very fun interactive stuff planned, and more details are coming out about that. It's going to be November 19th and 20th, so save the date. But better yet, we want you to give a talk. So if you are an avid reader of Hackaday and listener to the Hackaday podcast, you probably are doing something awesome that everyone else would like to hear about. You should give a talk about it.
How long are the talks going to be?
You know, we're shooting for 30 minutes, but there's a question on there about whether you think it's going to be too short, too long, or just right. So we might kind of move them around based on the subject matter.
Because a 30-minute talk is easy if you've got a good project. That's like the perfect length for, you know, something that it didn't take you a weekend to do it. It's maybe taken you a couple weeks to do it, but you know, it doesn't have to be like your life's work. A 30-minute talk is perfect for like, you know, this is the coolest hack I did last year.
So we'll put a form in the show notes for this. You can go read the article that's got a bunch more stuff on this. You know, we're looking for stuff that makes electronics happen. So hardware stories, software stories, skills, inspiration. You know, I like the sciencey stuff, and I know you do too, Elliot. So if you've done a bunch of experimentation in your lab for new processes, these are all really exciting things. Like, don't self-eliminate. Don't decide your thing's not cool enough. Like, put it in, I am hungry for things that I'm not doing in my own workshop. I want to see what you're doing. And so it's probably cool to a lot of people, and you're just too close to it to be as excited as you first were when you started it.
All right, and this morning we had a story about, well, the title is German Experiment Shows Horses Beating Local Internet Connections. And
Yes.
This was, this is a take on the old, you know, car full of tape drives. This is a man has to transfer, 4 gigabytes of photographs to a printer the town over in Germany. And this is in Oberkirchen in Schmallenberg. And, you know, it's 10 kilometers away. And he sends it by internet. It takes about an hour. He runs the opposite experiment where he burns it to a DVD and hands it to 2 teenagers on horseback in a bag that's labeled, you know, Pony Express, and sends it off. And it only takes them 10 minutes to get it there. So 2 kids on horseback can beat his internet connection.
Yeah. Well, it's a total stunt, right?
It's admittedly a total stunt.
Yeah.
And it's a great demo of what you can do if you just need to move a lot of data a small distance.
When so I like the stunt. I think that's funny. I think in the article, it was mentioned that, you know, it's not a great distance. Like if you're sending it across the world, it would be a different thing. You know,
yeah, you'd have to, the horse would be hauling to get over here.
I've actually considered the sneaker net. And actually,
Sure.
no, we've used the sneaker net.
We use it
before.
all the time in my house.
Well, so, but legitimately for Hackaday stuff. So one of them was like when we get a backup from our host for Hackaday.com, they only give us the database. They don't give us the media files because it's like, you know, 45 gigs or 55 gigs or something like that, a media file. So at some point I asked for a full backup to, you know, to make sure we had it. And I just couldn't get, like they put it in one archive, like one 55 gigabyte tar file or something like that. And it would just die. I couldn't get the transfer to continue. And so I was considering just shipping them a hard drive and having them ship it back. And I think the other one was for a Hackaday Belgrade. We had all the conference talk videos on a like solid state drive. And then someone in Serbia was going to do the video editing for us, and we ended up mailing the drive to Serbia because it was easier than trying to have them download all those, like, I don't know, super high res videos for that one.
I was going to say, I think it's standard practice in a number of industries where they're doing like film and super high data rate stuff. So you've just got a mass of data. At some point, it is faster to just put it on a hard drive and mail it over. But you know, one thing that's funny about this is he did this about a year ago, and since then he's actually gotten broadband in Oberkirchen or whatever tiny little town he lives in. Meanwhile, I, in Munich, granted on the outskirts of Munich, am suffering still with super slow internet, and they've been rolling out glass fiber to the home here, and we are in one of the zones that's not even planned to get it in the near future. So we know that we're not getting fiber until at least 2024.
Dude,
Yippee.
I have the tardy internet just because I'm way too cheap. I don't want to spend $100+ a month for internet, and then that's not even that fast either. But I mean, mine's something like 12 megabits per second.
We would pay for it willingly if we could, but this is c'est la vie.
This is a journey into sound.
What's that sound?
What's that sound?
What's that sound?
How did What's That Sound go last week?
Well, we were super glad that you left us a clip, but neither of us knew what it was. Although I did spitball on what it was.
Okay, and what did you say?
Video game. Some kind of video game.
Ah, that's not bad. That's true.
I put out a couple of thoughts, and then I didn't beep them because I didn't know if they were right or wrong.
Yeah, that's right. I didn't even tell you what it was. Man, that was mean.
No, it's not mean. It's cool. I thought there was pan flute in it.
Right? Okay.
Yeah. No, I don't know.
Have you looked at the answers for this yet that people have sent in?
Oh, no, I haven't.
Have a quick look at that and see if the Hackaday universe knew what this one was.
Holy cow. Looks like you've sorted them. We had 32 correct responses.
31.
Oh, yes. I never played this game.
Everybody got it right. Basically, this is one of those, we got 30-something responses, and out of the 30-something, 31 of them are correct. Not only that, but I got schooled. I was just like, I'll grab some Monkey Island music and play it, and a number of the people had pointed out that this is the Secret of Monkey Island special edition digital-only remix, not the original MIDI or CD-ROM releases. Touché, Redbeard. Monkey Island's really fun. It's like it's like an adventure game, but it's kind of sarcastic. It's kind of funny. It was influential for a lot of people, and a number of people even submitted nicknames from the game. So we got Matt's Revenge from a guy whose name must be Matt. Guybrush Threepwood III and Mancom Seepgood have all submitted answers to this. Correct ones, I might add. So good for all y'all.
Good for Tom Nardi, who said he thought it sounded like something from LucasArts.
Ah, something from LucasArts is spot on. It's not just something from LucasArts. It's the best game they ever made. Some would say. I think. And for the drawing this week, I was so excited that we got so many good answers. I went to my favorite source of random numbers. Well, my other favorite source. Last time I tried to draw a random number, Lava Rand was down. So I went to the NIST on this one, and I actually wrote an article 7 years ago about the NIST randomness beacon. I'll throw links into the show notes for you. If you don't know how the NIST random number beacon works, they draw a different random number every minute, and then they hash it together with the previous one. So it's like a blockchain of random numbers. So you can verify that none of the numbers have been changed, and they're all date stamped and time stamped. And so all of this is inside the hash. So you can verify that these are all completely random numbers, and you can pick a random number in the future. And so when I wrote the script, I haven't run it yet actually, I put a date out in the future that hopefully by now is in the past. And when I run this script, it's going to give me a random number instead of an error. So let's see if I did that right. And drum roll, please. The random number is 18. So congratulations to Lee, the Secret of Monkey Island theme. Congratulations. And the rest of you, if you've never played around with the NIST random number beacon, I've tossed a little bit of code in the show notes that will let you calculate the random number 18 and verify that I drew this one in this particular minute. So enjoy, and try to use the random number beacon more in your everyday life. And if you didn't win this week, and a whole bunch of you had the right answers, but the random gods did not smile upon you, we will be back next week with yet another sound snippet for you to guess.
Let's jump into our favorite hacks this week. Elliot, what is on your list?
This week, I'd like to start off with Minimill. It's a miniature 3D mill project. So is it a router? Is it a mill? Anyway, Paul McClay has made a really sweet one here. It is basically the minimum viable product, of home-built mills that can still do some reasonably good, precise work. And the trade-off he makes here is to have a stage that only moves about 10 centimeters in any direction. So it's 10 by 10 by 10. So it's pretty darn small. But the trade-off is it's also super precise. And so this is the kind of thing that's good for making tiny gears out of plastic or, doing, small PCB milling work or whatever. He's actually able to do aluminum with this thing, taking super light cuts, naturally. But when you look at it, you'll notice that the Z-axis isn't even strong enough to move the motor he's got in it. So he's got a counterweight hanging off the side, and it's a pop bottle half filled with water. I love that.
Yeah, it's really easy to dial in exactly the weight you need if you can just take a sip to lighten the load.
If you switch out the motors, you have to recalibrate it by drinking more water, I guess.
Yeah, I'm frankly shocked by the quality of the parts coming out of this. I mean, I've seen a ton of these mills that are kind of bootstrapped together and use a Dremel-like rotary tool, and I've kind of come to expect, a not small amount of slop in them. And boy, especially, I think he's got an upgrade that goes away from the rotary tool and goes to more of a spindle motor thing, and then he gets crazy good results out of that.
Yeah, and that by itself is kind of a sign that he's got something right, because just to get the motion stages down enough that it makes a difference to move away from a Dremel type thing to a purpose-built Proxon spindle, which is what he uses in this case, is already a sign that he's got it going right. And what makes this work is some clever selection of the linear stages. And the motors he picked, they look like the ones in CD or DVD drives. It's kind of got a stepper on one side and a long worm gear, and then something that slides along it. Except these are actually made fairly precisely and are extraordinarily cheap. They're like $7 or $10 each, depending on where you source them from, even though they're kind of riding on a medium beefy 6mm smooth rod. So it's kind of a really neat compromise build he's got here, but it makes doing it entirely yourself from scratch a lot more affordable than you might think it is otherwise. If you're looking at a tiny, cheap desktop mill, you might be looking at the kind of standard fare out of China 3018 mills. And he's actually got a log where he compares it to the best of the results he can find from people using 3018s in the internet. And he does better than that. And so I just love that using this kind of homebrew, but very well designed XY motion stage, he's able to get better results than kind of, what you might otherwise go to in the kind of sub $200 price bracket. That's the kind of money you got in your pocket and you're willing to build it yourself instead of get a kit. I would go this way.
Speaking of precision machines, I have always been fascinated by gaming controllers, and the newest one that's out there is the PS5 controller. And I know it had new joysticks in it, but I'd never looked into them. And that's why I was glad to see Donald Papp wrote an article called How the PS5's Genuinely Clever Adaptive Triggers Work. And this is kind of a mashup of a couple of different sources. There is a video from Tronics Fix that does a teardown, and then there is also some shots from iFixit that go in and look at this. But what it gives you a view of is the fundamental difference is this little motor that can move a stop in and out of kind of the backside of the triggers on these controllers. So traditionally, the trigger would be, would have a pivot point and a spring, and then it would move a trim pot, a trimmable potentiometer that you just read what the value is on that, and that's how you get your position. It's pretty easy. With this one, though, when you pull the trigger, this new controller has the ability to make it like harder or easier in order to pull that, or I think even to like make how deeply you can pull it change depending on what it wants to do. And it does this just with a little worm gear motor and a stop behind it.
Yeah, I looked at this and I watched a bunch of the videos. I was trying to figure out if the worm gear is driving backwards by itself, if it's back drivable, and also the part that the worm gear moves looks like it has a spring on it, and that's also attached to the trigger. And I couldn't figure out if the action here was it pressing directly against it or it tightening up that spring essentially to give you a tighter or looser spring tension, or resisting you with the motor, or what.
So I think that the trigger has its own spring. So if you move this stop out of the way, the trigger will work just exactly how it did with the previous, the dual shock, the 6-axis controller. I think that's what they call it. Anyway, the PlayStation 4 controller, PlayStation 3 controller. I think that the trigger part can work exactly the same way, but then this swings that little arm into place. I do see the spring that you're talking about, and I'm not sure.
Because I think it'd be really cool to make a variable tension spring, right? Because that, if you compress the spring more or less, that puts more force directly, like through the spring constant on your finger. You can still pull against it like you could pull against a spring. It's just a spring with a variable force. And then because it's on a motor, if you're like simulating a gun trigger or something, you could have it whip out of the way right when it hits the trigger point. And you'd get that feeling of pulling against the spring and then having it let loose.
Yeah, the backdrop ability is there though, so you can see that actually there's an animated GIF in the document here. And so backdrivable is when you move something connected to a motor, does the motor spin or not? Right. And this is one of the things I've been just drooling over on the X Robots channel. James Bruton's been working with a bunch of backdrivable motor designs for kind of like the suspension system on a quadruped, like a dog robot. Watching, what he's doing and seeing how it's important to be able to balance the strength of the motor and its ability to lift and move quickly with the ability to also have some give to it. And that is one of the questions that I have on this is like you introduce this new mechanism into the controller, and I'm always amazed at how much abuse these controllers use this thing for hours and hours and hours. The battery lasts a long time, even though it's got like vibration motors in there, and then I'm recharging it. And then years later, the battery's still good. Like I haven't had to replace the controller. And I think that engineering is just fantastic in those. And so I have faith that, Sony's figured it out for these as well. There's just so much risk in making changes and having them come out poorly that I don't think that they could take that chance.
All right, my next hack, GNU Radio decodes Voyager data, led me down a lot of reading. And this is by Daniel Estevez. You might recognize that name from his previous work decoding the Chinese Tianwen-1 probe. He and a bunch of other amateur radio enthusiasts got together to figure out what the messages that probe was sending back to Earth said. He's doing the same thing for Voyager 1 here. Along the way, I learned so much. I learned about the Berkeley's Breakthrough Listen project, which is kind of a successor to SETI. And they've got a bunch of satellite telescopes, about 300 times more bandwidth than SETI ever had, covering a lot more of the sky for a lot more of the year. And they're collecting all this data, and they're actually making it available, among other things, to us. Daniel took a slice of this data from the 30th of December 2015 that had Voyager 1 telemetry data as it was, I guess, past the edge of the solar system by that point in time, and took to decoding it. The other thing Daniel's done is worked on GR satellites, which is the GNU radio satellite decoder package of choice. And that's because he loves decoding satellite data. And if you go through this write-up, it's just a phenomenal introduction to, first of all, how you could use GNU Radio and GNU Radio Companion, the kind of graphical overlay, to put together this kind of flow, but then also all sorts of interesting information about satellites, how they encode data. It's archaeology here. Like satellites put out a 32-bit signature, and so you can use that to tell when a packet starts, right? You look for this 32-bit code. And Voyager does too, but it's actually so old that it doesn't use the standard one. And so he asks around in the radio astronomy community, and somebody tells him what the attached synchronization marker, the ASM for this is, and that lets him figure out where the packets begin and end. But then he can also type this magic 32-bit number into Google, and he finds tremendous documentation about how Voyager's telemetry radio stuff worked. And he gets to plug that all in. This article has far too much to talk about on the podcast. If you're interested in satellites or radio or GNU Radio, you absolutely should check it out. Last September at GNU RadioCon, Daniel gave a great talk on decoding satellites, and this was a lot of his Tianwen-1 work. This year, he's giving another talk, and it's going off on the 22nd, so you can watch it happen live. I'll throw links in the show notes. And just it's definitely rocket science.
Well, just looking at this and thinking, what a great resource to be able to have the files listening to this. Because, regular people are not going to ever get time on the telescopes.
Correct.
But that doesn't mean that we shouldn't share the wealth on what's there. And then you just get a lot of brilliant people who are not going to spend their life working as radio telescope signal analysts, but might spend their hobby hours of their life working on it, and that, could make a breakthrough or, not.
Yeah,
maybe
right?
Just have a bunch of fun. The other thing I was looking at this, and I'm like, man, wouldn't it be amazing if computer club at school is let's look at what it takes to decode satellite data. Where do you grow up those engineers who are going to, design these satellites and work on the projects that are listening and all of that stuff? This would be a great way to onboard more people into that too.
Yeah, and on that vein, heavy kudos to the Breakthrough Listen team. They have a GitHub that's just full of Python code that walks you through handling this data, because the data is like a fire hose. It's 10 gigahertz of data sampled at 8 bits. It's too much. But they have all sorts of great tools for how you hone down in on the parts of the spectrum that you're interested in. And they do try to make it accessible for you to do so. This is I've always wondered why it takes radio astronomy people so long to get their results. They do this observation 4 years ago, and then they crunch the data, and then they come up with something. This is we already kind of know the answer, but these are all the steps it takes to chunk through that data. And I get it now.
All right, one of my favorite hackers of all time, Matthias Wandel, has been at it again. And I got to say, Elliot, this is crazy that on his secondary channel, where it's for the other stuff, we get something as cool as this, which is how you can build your own inductive current sensor, and then how you can use it to test what it takes to throw a breaker on one of the circuits in your house.
Ah, cool.
So he has a ton of equipment in his wood shop that's going to be using this power. He'd like to be able to monitor it, and he'd be able to look at a whole bunch of stuff, but doesn't want to cut open some of the Romex cable in order to get a current sensor to wrap around just one of the conductors, which I'm a little confused on that, because I thought they made ones that you could do without that, but he seems to feel like you can't. And so he goes about wrapping his own loops of coil and then doing the signal smoothing in order to take accurate readings on that.
The thing he's doing that's really clever here is usually you put the loop around the wire, so you worry about the flux flowing through the loop. And what he's doing here is he puts the loop on the side of the wire. So as long as the wire has the hot on one side and the neutral on the other, and it's not twisted, he's got coupling between one side of his loop on one side and the other side of the loop on the other. So it's kind of, I don't know if it's a novel design, but it's not one I've seen before.
Do you normally need to split open the Romex so you can put your sensor, just the clamp sensor just around one conductor?
Yeah, if you're going to do it with what I would call axial arrangement, where you have the conductor going through the center of the loop, you definitely do, because like the field coming from the current going in one direction cancels the one going in the other direction. And so you split that apart, and so then you can wrap the core around just one of the two wires.
I guess maybe where I've seen them is inside the circuit panel or the breaker panel. So in that case, you're only getting the hot going to the breaker. And because, the Romex is generally going to be inside the wall, but for some reason I just kind of equated the two. So that is an interesting problem that he's got. Now he takes, 10 inches long piece of wood, and he does 20 wraps of magnet wire around it, ends up not getting a very good signal out of that. He goes further to then wrap that in tape, then wrap it in aluminum foil, and then wrap it in tape again. And, I'm looking at this and I'm like, yeah, that's exactly how shielded cable is made. It's not like there's some exotic material that's going into shielding. Like it's just foil and tape. Even though it's not being made in a factory, like that's a rather high end, antenna that he's made in order to sense it. He has to do some filtering on it, and I think it's just a ripple filter, right? So it's an inline resistor and then a capacitor, and then that filters out some of the high frequency noise that's on the line.
Ah, cool.
I'm not sure why at the end of it, he says that he gets a lot more sensitivity out of the professionally manufactured clamp sensor that he has, but he does in another part of it get a strange kind of metallic core that he kind of wraps around one side of this loop as it's going along the power cable, and that does a lot for it. But he ends up moving from just utilizing, I think it was a Raspberry Pi's ADC, and
right?
He gets an ADC chip so that he can take a lot faster measurements of it. There's an interesting story in there. He gets a counterfeit chip, and then he ends up buying the board from Adafruit, and he gets the right chip. And the actual chip on the Adafruit board has better resolution, but for some reason the fake chip, he's able to take samples faster. So he actually finds out that one is doing a better job of measuring. But of course, looking at his experiment, some of the just brilliant takeaways of it is he's running a Python script in order to measure this stuff and display it out. And he's putting the number on the left column, but then he also maps that number to like a number of like pound signs across the screen. And so what you end up getting is a text bar graph going in real time, which is great because then, you don't need to deal with the numbers, which don't mean that much anyway when you're just kind of bootstrapping a system like this. But eventually gets to the point where he's measuring the actual amps that are going through this because he's calibrated it with like a kilowatt meter. So you can kind of figure out what it actually is, and goes up to something like 136 to 145 amps before it trips the breaker.
Well, speaking of shiny, this is one of the cooler home automation projects I've seen in a while. A video from Nerd Axic. GLaDOS voice assistant passive-aggressively automates home. This is like a fantastic mashup of a million things from the internet. Instead of using an Amazon Alexa or whatever, he wants to make his own replacement, and he wants to give it some style. And he'd seen a really nice animated GLaDOS from the Portal game series on the internet somewhere with complete open source designs and plans. So he's like, I'll just make me up one of those, embed a talking voice recognizing home automation robot in it, and I will have something that can threaten to kill me and or turn off the lights in my room. And this ends up being one of the closest to full-on replacements for an Alexa-like device I've ever seen. It's using Pocket Sphinx for a wake-up word, so that's open source. It's using the Respeaker mic array, which is Seed Studios puts this out. It's a kind of an 6 microphone speaker array that you can.
So this new one has 4. So I actually looked into it because I haven't seen it since one of their first ones. Well, they say that the processing chip has gotten enough extra features into it that it can be get really great direction finding based on 4 microphones.
Oh, that's fantastic. And it's got a Raspberry Pi, and it's got, it's all written in Python. It's extraordinarily accessible. The only thing that isn't open source and free and controlled by you and hackable is that still he's using Google's API for the speech-to-text stuff. He says in his GitHub repository, for now, and I'd love to see him step away from this, because then you could do everything locally. It would be a lot faster. It would be a lot more privacy respecting than shipping your data out to the cloud. It would be really fantastic. And I think we're right on the edge of something like that for kind of DIY home automation. I'm excited to see where this goes.
Yeah. So you are someone that has voice activated stuff in your house. You've got the Amazon box. I look at that and I'm like, that's interesting. It bothers me a little because I don't want to have to talk to do things. Like, I still like interfaces that you have the option of, like, it'd be nice if you had the option of pulling out your phone and doing the same stuff. And I think if you're building your own through Home Assistant, then definitely you can do that. Part of the problems here, he talks about words that aren't in the training set. So like GLaDOS is not in the training set. So if you want to, and by training set, I mean that there are voice command training sets already available out there that have had a ton of different samples been put in there, and they're going to be really good at hearing a man or a woman or a child or an old person or a person with an accent and still understanding them, where if you're trying to train it yourself, that's going to be difficult. But part of the problem is, if there are words that aren't in those training sets, then you're going to have less accuracy on those words. So like GLaDOS is one of those. But the other one is just like maintaining the system. So like the more bells and whistles that you add into it, the more that you're going to have to upkeep it. And I kind of worry about that technical debt.
I kind of really like that aspect of it. If you haven't looked at his GitHub repository, you really should, because it shows you how kind of all the other tools people have built make it extraordinarily simple to cobble something together like this with just a few lines of Python. Right? Like, it's really not much code out there, and there's not much technical debt, I think. And I think part of that is that he's realized that he only uses a few features anyway. Like, he wants to be able to get the weather, put things on his shopping list, and, I've forgotten what else it is, but frankly, that's all we use it for. That plus listening to music is all we use ours for. And if we could get rid of it, we would all be happier. Especially if we could get it to play our local music that we have on our local file share, our local file server. Like, we could play our own tunes without having to convince Amazon that we've already purchased these CDs. There's a whole rat's tail with the service that you could just end run around if you could just write a Python script to have it do what you want. The speech-to-text part is what's the hardest right now, and I don't know. I'm interested to hear if anyone out there listening knows of a good competitor to the kind of Google API or the Amazon APIs for this. I've seen work coming out of Mozilla with their machine learning speech-to-text program, and so I'll throw a link in there. Like, you're worried, Mike, about the putting together a DIY solution and having it fail later, or being the only person maintaining it. Yeah. And I think this is almost to the point that it's ripe for a community solution. So, would you be happy if there were a project that everybody was working on doing this sort of thing, and you can just, pull the repo, it's a bunch of easily inspectable, hackable Python files. You would love that.
Yeah, well, part of my worry is that, you upgrade something and then all of a sudden you have a package dependency in Python and you can't get it to recompile and you're like, oh, now my system doesn't work. So there's headaches like that. But at the same time, as much as I'm thinking like, oh, I'm probably not going to ask for Google searches or DuckDuckGo searches with my voice. Like,
no, those are horrible.
There's just an easier way to do it. Basically, every time I wash dishes, I'm listening to a podcast.
Right.
And it'd be really nice when your hands are, in greasy suds to be like, GLaDOS, pause. I also think that you need something that will listen for swear words and play that thing from Demolition Man where it reads off the citation and finds you. Definitely need that.
Read more Hackaday. For science. You monster.
All right, let's finish up with an amazing piece of hardware art. This is Chris Combs's clock wall hanging display. I'm not sure exactly how to say it, but it is a 7,200 segment display. We normally talk about 7 segment displays that could be used to show the number 8. This is a series of modules for that. So it's 288 modules. I would call them 3.5 digit modules because the leading digit is a 1 instead of an 8, but it would be 4 digit spaces on this. They've been put together into a nice extruded rail frame and hung on the wall, and then driven like it's just a regular LED matrix. And so you light up the different segments not based on whether or not they should be showing a number, but based on a shape that you want to show on the larger display.
It's like ASCII art done on 7-segment clock displays, but many of them.
Yeah, and it's gorgeous. Like the way that it's done just looks fantastic.
So cool.
And then Chris has a real cool trick up his sleeve. So he's actually driving these with the IS31FL3733, right? You know that one?
Yeah. Point 2.
This family of drivers, if you've ever had to drive a bunch of LEDs, you probably know these IS chips because you basically give them the data and they take care of everything else. So they handle the matrix scanning, and they can even assign brightness levels. So they're doing the pulse width modulation by themselves. So this actually has 8 bits of grayscale brightness. And there's one in-body image here where you can see that all of the digits on the entire display are lit up, but then like the time is kind of meta lit up over the top of that in a brighter shade.
He says that he stumbled into a cheap bid on eBay and had to buy like a mazillion of these little displays. And I can imagine having done this and woken up the next day a little bit hungover and been like, oh, what am I going to build with all these now? And this is the beautiful solution to that dilemma.
So even if you don't care so much about the application and the segments and stuff, it would be worth looking at this and keeping in mind because he talks about driving this many displays from a Raspberry Pi. And one of the tricks is to enable multiple I2C buses from the Raspberry Pi. And that involves working with the device tree. So if you're looking for a roadmap or a cautionary tale of the pain that you should avoid, then that's one place you can find it.
My first quick hack this week, 3D objects without scanning. Samuel Garbett runs through how to make 3D models from photos of objects in Blender. This is to make them exactly the right size and shape so that you can integrate them into a larger project or whatever. It's just a nice tutorial about how to do this particular stuff in Blender. I've experimented around recently with doing similar stuff in FreeCAD, and I have to say it's an awesome tool to have in your toolkit. So check out his website. Next up, Vector Collector Inspector, an art project by Nicholas Roy and Kati Hypa. Nicholas has been working on a graffiti spraying robot all summer that's basically just a 2D plotter that spray paints graffiti. This is kind of a spin-off of that. It's a small paper plotter with a joystick and a pen up, pen down button. He and Kati mount it in a movable wagon so they can take it out and have people just play around drawing pictures on it. It records what they do. It actually saves them in an open source database of these fun graffiti people make, and then he can use it later to spray paint it on the wall. Last up, Useless Machine is a Clock. This is a crazy video by Burke. It is an analog clock that has a camera and a Raspberry Pi in it. It uses OpenCV to tell when you're looking at it and then fires off a servo to knock itself off the wall. So you can tell what time it is once before this thing commits suicide. It's the Useless Machine clock version.
First up on my list of quick hacks is Thick GBASP mod gets easy install ahead of release. This is an awesome way to take your Game Boy Advance SP, replace the bottom of the case, and put a bunch of upgrades in it at the time. So the biggest one is the battery. So you get a 4,500 milliamp hour battery. But hey, while you're already in there designing a new part of the case, you might as well throw in some more stuff. And that involves Bluetooth audio and Qi wireless charging and USB-C charging as well. Next up, making a car key from a ratcheting wrench. Lewin Day wrote this article about one by Well Done Tips. You're going to need an older car for this, one that doesn't have that security chip in the key. But otherwise, you can grab yourself a little ratcheting wrench, shave down the handle of it, and then very carefully by hand trace out all the ridges to cut your very own key. I've never seen someone make a key from stock material before. I've always seen them make it from key blanks, and it's a fun watch just for that reason. But of course, if you have a classic car, it's begging for this key. And finally, putting thousands of Minecraft players on the same server. Matthew Carlson wrote this about an epic software hack by Jackson Roberts. If you've ever played Minecraft online with the servers, you know it's usually limited to a certain number of players. I think like 16 players might be where it's at. But what if you wanted to play with hundreds or even thousands of players? I can think of the crippling server lag that you would have to deal with. Well, the answer that Jackson came up with is to stitch together multiple servers and make it scale in real time. So as the load goes up, more servers go up, and they basically offload what is happening in some of the chunks to different servers, so that you have, more computing power to do it. Something that would probably be a good thing to do with the stock game itself. It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday authors. Elliot, you're up first.
This week I wanted to start off with Lewin Day's The World's First Autonomous Electric Cargo Ship is Due to Set Sail. And this is a really neat idea anyway. If you think about like autonomous navigation on the streets, there's all of this traffic and it's unruly and full of crazy erratic drivers. If you think about large ships sailing the oceans, they all follow the same routes. They all have beacons on them. The oceans are actually pretty big. They're not going to run into each other anyway. It's the perfect test bed for autonomous driving. The second trick here, though, is the more interesting one. It's that these ships are completely electric and they are aiming to reduce pollution. This is a test ship to try out whether it's possible to run all electric instead of diesel in large tanker ships. And I thought it was really cool. It was fun to read this one. It's fun to see what counts as a big ship and a small ship, because these ships can only carry about 60 containers, whereas the big ones, the numbers of containers on them are up in the thousands. And the ship's only also taking short runs. So it's sailing around Norway and not, across the Atlantic. But, you got to start somewhere first. And it's really interesting to see that you can actually make something that, for me, seems like a big ship, even though in the scale of cargo ships, it's a small one, run entirely on batteries.
So first of all, this is not a huge ship, and it's not going a long way. And I think that's fine, because I don't want to put the Ever Given under robot control as our first as our first try out. So you don't have a problem with that. It's going to do its test run from, and I cannot pronounce these, I'm sorry. So the American vernacular is Heroia and Brevik. Which I looked it up, and that's less than 10 kilometers as the crow flies, but you've got to steam around the Horn of Norway. I know it's not called that, but it's kind of funny if you say that. And they've done some, semi-truck autonomy tests in the United States where they're not going, huge diffs. They're going 10 or 12 hours or something. That wouldn't have been impossible for a team of human drivers. It's not like it's game changing in that way, but it's testing the waters, in order to see what the autonomy is. One of the points in here that I thought was interesting is it's going to be able to autonomously dock.
Yeah.
Which, yeah, okay.
That's the part I would have thought they would have hauled in actual captains for.
Well, when you dock, you're using the help of tugboats and local captains, right? So you get usually if you go into a port, they have a port pilot, I think they call them, that comes on board and takes you to the port. I don't know. I mean, there's human error on those, right? That damages the port. There could be machine error here. I don't know. So it's good to do these tests and to see. I don't understand the need there. So the autonomous thing is kind of scratching my head, wondering what's going on. The electric thing is more interesting to me though, because for instance, electric planes are not really going to be a thing because you need the weight to energy density of like the liquid fuel because batteries just can't keep up with that. But when you're floating on the ocean, like you could have literally tons and tons of batteries. And even if they were heavier than the same amount of fuel oil for the power, it's not really that big of a deal, right?
What I found really interesting about this was actually how small the battery was. Like this is for me, a big boat. It can carry a whole bunch of containers. And the battery pack is a 7 megawatt hour battery pack, which again, for me is a big battery pack, but it's only about 70 Tesla Model S battery packs. Yeah. And this thing could carry significantly more than 70 Tesla Model S's. So it makes you think about how efficient boats must be in a way. I guess they don't have much resistance as they plow through the water. What you were saying with the battery weight's absolutely true, and I wonder if ships aren't also more efficient as they go along. Be an interesting experiment. I want to see how it works out.
All right, let's close up the show today talking about hitting asteroids with stuff. NASA are squaring up against the asteroid threat. Luende also wrote this one, and this is about the DART program, the Double Asteroid Redirection Test, that is going to be taking place on a binary asteroid system. Didymos is a 780 meter in diameter asteroid that has another asteroid, Dimorphos, revolving around it. And we are going to send out a 1.2 by 1.3 by 1.3 meter probe to smack into it at an insanely high speed.
I love this. It is actually shooting at asteroids, and I guess you want to practice that before you need to do it for real. But like the idea here is that this asteroid isn't going to get very close. I guess it says in the article 11 million kilometers without being on a collision course for Earth, making it a good candidate for humanity's first attempt at asteroid deflection. I hope they send it in the right direction. We had this asteroid that was only gonna travel 11 million kilometers away, and now we've sent it on a collision course for the Earth.
Someone was asking this, aren't we going to hit it after it passes?
Oh, that would be smart, wouldn't it?
I don't know, but yes, it does sound like it would be smart. Let's just assume that we're not going to end up accidentally hitting ourselves.
Right.
With this.
Totally.
But the sheer difficulty of this problem, I mean, 780 kilometers in width is not very big. Right. And then the 1.3 meters across on the widest spot is not very big.
Right.
And we're shooting it from a long way away. And then it's going to be going, 6.6 kilometers per second is 23,759 kilometers per hour, or 14,764 miles per hour.
Okay.
And I put those in there because I do better intuitively with miles per hour.
For sure.
I mean, that's like super duper fast. And if anybody has ever played Rocket League and tried to jump their little car into the air and use the rocket to hit the ball, almost always the ball flies past without you making any kind of contact with it at all. It's a really hard problem. And, that's just like a little tiny video game. This is going to be done autonomously.
Would have to be.
Obviously, because of my sucking at Rocket League, you're not going to just have someone at NASA on a joystick you got to calculate this out, right? And so they have a really cool optics system to make sure that the autonomous algorithm has good inputs. And then in order to study what happened, it's going to pop out a little CubeSat before it makes its final run, and the CubeSat is going to be the front row observer. How cool is that?
That is super cool. And this is both significantly more plausible and less dramatic, but still more awesome than all of Hollywood's vision of what we would have to do to defend ourselves from it. There's no nuclear explosions. In fact, there's no explosions at all. In fact, they're trying to make sure they keep the rock intact. They just want to push it, right? And so they have to hit this thing, but they don't want to fracture it and send bits flying everywhere. That would be dangerous. So it's a really neat experiment. And I guess it just strikes me as somehow really gonzo to shoot a rocket at an asteroid.
I mean, somebody at NASA decoupaged pictures of Bruce Willis and Ben Affleck on the inside of the case of this probe, right?
How do you go about getting permission to do this? Do you just call up the asteroid owner and be like, we need to shove your asteroid for a test? Would that be okay?
It's in international waters, so it's fair game.
I think that's right.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, tell us about it. tips@hackaday.com. And until next time,
keep on hacking.
It probably doesn't make you happy when I'm clicking while I'm talking, does it?
Okay, kick your butt.
Why prepare early when you can hold everyone else up? Hold on, my internet's slow. Da-da-da-dun. How to end this one?
Segue into that better, and I'll just cut out me saying stupid stuff.
If I can find my recording thing. Stop.
Ta-da.